Section 1 on linear and absolute value equations. First, we're going to start off with linear equations, and specifically linear equations in one variable. An example of such equation is given to us in problem 1.1, where we are asked to solve for x and then check the solution. So the equation given is 4x plus 1 equals to 2x plus 7. So since our goal here is to solve for x, we must move all the variable terms to one side and all the terms without variables, which is the constant terms, to the other side. And we can begin to do this in any of the 4 different ways. And the reason it's 4 different ways is because we have 4 different terms. However, once we choose our first step, the subsequent steps are fixed. But regardless of which term you start moving, you should still get the same solution in the end. Okay, so for now, we're going to move 2x to the left side with the 4x. Okay, and also remember, just because you're dealing with an equation, what you do to one side of the equation, you have to do the same thing to the other side of the equation. Okay, so let's subtract 2x from both sides of the equation. And the reason we are subtracting 2x is because here 2x is positive, right? The opposite operation of addition is subtraction. So we are subtracting 2x because we wanted to move it to the other side. So subtracting 2x from both sides will make 2x cancel out on the right hand side. The left hand side becomes 4x minus 2x, which is 2x. And our equation now becomes 2x plus 1 equals to 7. Okay, the next step is to move 1 to the right hand side. So because 1 here is positive, in order for us to move it to the other side, we need to use opposite operation. So opposite operation of addition is subtraction. So we are subtracting 1 from both sides. Okay, subtracting 1 from both sides. So 1's will cancel on the left. And on the right hand side, we get 7 minus 1, which is 6. So now our equation becomes 2x equals to 6. And the next step is to get rid of the 2 in front of x. So we need to divide now both sides by 2. So dividing both sides by 2 will make 2's to cancel on the left. So we're left with x only, and the right hand side becomes 6 divided by 2, which is 3. So we ended up getting x equals to 3. The next step is to check our solution. In order to do that, we need to substitute our solution into the original equation. Okay, so you start with the original equation, and everywhere you have an x, you're going to replace that x by your solution, which is in our case 3. So everywhere we have an x, replacing that x by 3. Now, watch that we have a question mark here, and the reason we have a question mark there is because we are checking if the left-hand side of the equation is equal to the right-hand side of the equation. Okay, so let's do them separately. So on the left-hand side, we get 4 times 3, which is 12. 12 plus 1 becomes 13. Now let's move on to the right-hand side. On the right-hand side, we get 2 times 3, which is 6. 6 plus 7 is 13. So we ended up getting a true statement because 13 is equal to 13. And because the statement is true, that means our answer is correct. And therefore, x is equal to 3 is the solution to the given equation. Okay. So now we mentioned before that there are 3 other ways to start the problem. We did the problem by subtracting 2x first. What we could have done is subtract 1 first from both sides, or we could have subtracted 4x from both sides, or 7 from both sides of the equation. I'm going to leave out the steps for you guys to go through, and if you do have any questions, let me know. I will go over that. But you can see that regardless of which way you start the problem, your solution at the end is still the same. Okay, so you may use any of the above to arrive at the correct answer. Alright, so let's take a look now at other examples of equations. Before we get to other examples, let's take a look at distributive property. So some examples involve multiplication with parentheses. Okay, and we must understand the distributive property to solve these problems. So for example, you have 3 multiplied by the quantity 4x plus 3, and that is equal to 12x plus 9. So to remove those parentheses here, we need to use distributive property. Okay, so distributive property is defined for us below. So when you have the quantity A multiplied by the quantity B plus C, that is equal to AB plus AC. So what this means is when we multiply a quantity A that is outside of the parentheses by 2 or more quantities that are being added or subtracted inside of the parentheses, then we must multiply the quantity on the outside by each of the quantities inside of the parentheses. Okay, so when you multiply A times B, you get AB. When you multiply A times C, you get AC. And that's how we get rid of the parentheses. So the same happened in the example above. So when you multiply 3 times 4x, you get 12x. 3 times 3, you get positive 9. Okay, so now let's take a look at an example where we are going to apply distributive property. So example 1.2. We are asked to solve for x and then again check the solution. So 3 multiplied by the quantity 3x plus 7 equals to negative 5x plus 7. So we'll begin by applying the distributive property on the left-hand side, and then we'll proceed as usual. Okay, so applying distributive property, we get 3 multiplied by 3x, and then 3 multiplied by 7. So 3 times 3x, that's 9x. 3 times 7, that's 21. Okay, so now we have an equation 9x plus 21 is equal to negative 5x plus 7. So now we can solve this problem by taking any of the 4 terms, either this term, this term, this term, or this term, and we can move any of them from one side to the other. What we are going to do is we're going to start off with moving the 5x. Okay, so since there is a negative 5x, the opposite operation of subtraction is addition, so we are going to be adding now 5x to both sides. So negative 5x and 5x will cancel out on the right hand side. On the left we get 9x plus 5x, which is 14x. And our equation now becomes 14x plus 21 is equal to 7. Next we're going to move the 21. So we have a positive 21. The opposite operation of addition is subtraction. So we are going to be subtracting 21 from both sides of the equation. So on the left, the 21s will cancel. So we get 14x is equal to, and then 7 minus 21, that's negative 14. Okay, the next step is to get rid of that 14 in front of x. So we need to divide both sides by 14. Okay, so dividing both sides by 14 will make the 14s to cancel on the left, so we left with x only, and the right hand side becomes negative 14 divided by positive 14, which is negative 1. So we ended up getting x equals to negative 1. Now the next step is to check our solution. So again, you're starting with the original equation. Okay, and then everywhere you have an x, you're replacing that x by your solution. So in our case, the solution is negative 1. So in those two cases here and here, we have an x and we're replacing those x's by negative 1. And again, we have a question mark here because we're checking if the left-hand side of the equation is equal to the right-hand side of the equation. Okay, so first we're gonna work with the left-hand side. And we are going to work with inside of the parentheses first. Okay, so inside of the parentheses we have 3 times negative 1, which is negative 3. Negative 3 plus 7 becomes positive 4. And then 3 times 4 is equal to 12. Okay, so the left-hand side is 12. Now let's take a look at the right-hand side. We have negative 5 multiplied by negative 1. That's positive 5. 2 negatives will give you positive 1 multiplied. So we get 5 plus 7, that's also 12. So again, we ended up getting a true statement because 12 is equal to 12. So that means our solution x equals to 1 is the correct answer. Okay, so that is the solution to this equation. Now please work on the next 4 examples here. And the next topic is absolute value. So what's the definition of the absolute value? The absolute value of a number x is defined to be the distance of x from 0. Okay, and this is how we write it in symbols. This is the absolute value of x. So using above definition, we'll see that the absolute value of 4 is equal to 4 because the distance of the number 4 from 0 is equal to 4. Now if you look at the number line, this is a 0, 1, 2, 3, 4. And if this is the 4, how far is 4 from 0? What is this distance? How many units away is 4 from 0? It's 1, 2, 3, 4 units away from 0. Okay? Now similarly, the absolute value of -4 is equal to 4 because the distance of -4 from 0 is also 4. Now let's take a look. -1, -2, -3, -4. How far is -4 from 0? How far is it? It's 1, 2, 3, 4 units away from 0, right? It's 4 units away. So the absolute value of 4 and the absolute value of -4, they both equal to 4. Okay, so now let's take a look at problem 1.7. We asked to evaluate given values. So what's the absolute value of 7? It's 7, right? 7 is 7 units away from 0. What's the absolute value of -5? It's simply 5. What's the absolute value of -13.45? It's 13.45. What's the absolute value of -3,458? It's 3,458. What's the absolute value of 0? It's simply 0. So please note that whenever the number is positive or 0, the absolute value is equal to the number. And whenever the number is negative, we have to change the sign of the number to get the absolute value. Okay, so recall that changing the sign of a number is the same as taking its negative. So this leads us to a different way of thinking about the absolute value. So another way to define what the absolute value is, alternate way of writing definition is absolute value is equal to x if x is greater than or equal to 0, and it's equal to -x if x is less than 0. So by this definition, if we wish to calculate the absolute value of 17, because 17 is a positive number, right? That means we'll be using first half of the definition. And that says, if your x is greater than or equal to 0, then your answer is simply x. So therefore, the absolute value of 17 is equal to 17. But now if we want to calculate the absolute value of -17, we're going to be using the second half of the definition because our x is now less than 0, because -17 is less than 0. Right? So this says that what you're going to do is you're going to put an extra minus in front of your x. So our x in itself is -17. Now if you put an extra minus in front of it, you're going to get 2 minuses, right? So 2 minuses here will give you a plus. It's like -1 multiplied by -17. That becomes positive 17. Okay, so again, we still ended up getting the same solution. It's just a different way of using, of thinking about what the absolute value is. So now using above definition, let's try to work out problem 1.8. So again, let me rewrite the definition. So the absolute value of x is equal to x if x is greater than or equal to 0, or it's negative x if x is less than 0. So now, since 8 is greater than 0, that means we're using first part of the definition. So that simply says your value will be equal to 8. Now, absolute value of negative 7, since our x is less than 0, that means we're going to put in the second part of the definition that says you're going to put an extra minus in front of your x value. So there's an extra minus, and my x value is now negative 7. Two minuses will turn into a positive, so what I get is, in the end, positive 7. The absolute value of negative 5.309, again, x is less than 0, so that means put an extra minus in front of your number. Again, two minuses will give us a plus, so in turn we get 5.309. The absolute value of 0, well, that belongs to the first half of the definition because x is greater than or equal to 0. Okay, so that simply says, okay, that's going to be your value. Whatever your x is, you don't make any changes to it. And the last one, we're dealing with x less than 0. So again, we're using the second part of the definition that says put an extra minus in front of your number. So that becomes two minuses again turned into a positive, so we get 123. So now let's take a look at equations involving absolute values. In problem 1.9, we asked to find the solution set of the equation. So the absolute value of x equals to 3. So here we are being asked to find the set of all possible numbers whose absolute value is equal to 3. And we know that there can only be two such numbers, namely positive 3 and negative 3. Therefore, we only have two solutions, x equals to 3 and equals to negative 3. So our solution set is 3 and negative 3. Now problem 1.10 is a little bit more involved. Let's take a look. Find the solution set of the equation and then check your solution. So we're given the absolute value of 3x plus 2 equals to 7. So now notice that the expression inside the absolute value symbol is now 3x plus 2. Therefore, there are two possibilities. One is that we either going to have 3x plus 2 equals to 7 or 3x plus 2 equals to negative 7. Okay, so these two equations must be solved separately to get the solution set. Okay, so let's first start solving the 3x plus 2 equals to 7, and then we'll move on to the other case, 3x plus 2 equals to negative 7. So to solve 3x plus 2 equals to 7, first we're going to move 2 to the right hand side. So we are subtracting 2 from both sides. That makes 2's to cancel on the left. So we're left with 3x is equal to 7 minus 2, which is 5. And then we wanted to get rid of the 3 in front of x, so let's divide both sides by 3. So dividing both sides by 3 will make 3's cancel on the left. The right hand side becomes 5 divided by 3, which is 5 over 3. We can leave it as a fraction. And the right hand side, here we have 3x plus 2 equals to negative 7. So the goal is now first to move the 2 to the right hand side. So let's subtract 2 from both sides. The 2's cancel on the left, and the right hand side becomes negative 7 minus 2, which is 9. So now we have 3x equals to negative 9. To get rid of the 3 in front of x, we divide both sides by 3. Okay, so dividing by 3 on both sides makes 3's cancel on the left, and the right hand side becomes negative 9 divided by 3, which is negative 3. So we ended up getting two solutions, x is equal to 5 over 3 and x is equal to negative 3. So our solution set is 5 over 3 and negative 3. Let's check to make sure we have correct answers. So when you're checking again, you're going to substitute each of your solutions into the original equation. Okay, so you're starting with the original equation. First, you're going to check the value of 5 over 3. So everywhere you have an x, you're going to replace that x by 5 over 3. And again, you have a question mark here because we're checking if the left-hand side of the equation is equal to the right-hand side of the equation. Okay, so now let's simplify the left-hand side. So we have 3 multiplied by 5 over 3. So if you like, you can rewrite 3 as 3 over 1. This way, you have a fraction multiplied by a fraction. Now we can see that 3 cancels with the 3. So we are left with 5 divided by 1, which is simply 5. And then 5 plus 2 becomes 7. The absolute value of 7 is equal to 7. And the right-hand side, there's only number 7 there. So what we ended up getting is 7 equals to 7, which is a true statement. Okay, so that means x equals to 5 over 3 is the correct answer. Now let's take a look at the other solution. X equals to negative 3. Again, we're starting with the original equation. Everywhere we have an x, replacing that x by negative 3. So negative 3 times negative 3 becomes negative 9, plus 2 becomes negative 7. The absolute value of negative 7 is positive 7. And again, the right-hand side is equal to 7. So again, we ended up getting a true statement where 7 is equal to 7. And that means x equals to negative 3 is also a correct solution. So we ended up getting 2 solutions. Okay. Now, the main idea above is that any equation involving the absolute values will eventually split into 2 equations. Okay, then we will solve those 2 equations separately to find our solutions. Okay, so that's the main idea in solving such equations. So you're starting with some absolute value. Now, absolute value has to be isolated. There's nothing in front of the absolute value. There's nothing behind it. Okay, just an equal sign. Once you get it in that format, then you split it into 2 cases. The first one is ax plus b equals to c, and the second one is ax plus b equals to a negative c. Okay, so based on that, let's work on these problems here. Okay, and I will move on and consider problem 1.13. Find the solution set of the equation and then check your solution. So here, not only we have an absolute value, we also have other terms that are being multiplied by and subtracted from the absolute value term. Okay, so our goal here is to isolate the absolute value. So that's your first goal. And then once you isolate your absolute value, you're going to split into 2 equations and solve it just like we did in the problems above. Okay, so our goal is to get rid of the 8 and get rid of the 3. Okay, so first step is we are going to be adding 8 to both sides of the equation. That will make the 8's to cancel on the left, and the right-hand side becomes 7 plus 8, which is 15. The next step is to get rid of the 3 in front of the absolute value. So we are going to be dividing both sides of the equation by 3. Okay, so the 3 will cancel on the left, and the right-hand side becomes 15 divided by 3, which is 5. Now we have the absolute value isolated. So what we can do is now split into 2 equations. So this will be the first equation, and this is the second equation. So the first one is 4x plus 1 equals to 5, and the second one is 4x plus 1 equals to negative 5. So this is the difference. This is negative 5, and this is the positive 5. That's the only difference. And now we need to solve each one of them separately. So subtracting 1 from both sides here first will make 1's cancel out, and we're left with 4x on the left equals to 5 minus 1, which is 4. And we wanted to get rid of the 4 from the x, so we're dividing both sides by 4. So the 4's will cancel on the left. 4 divided by 4 becomes 1. So the first solution is 1. And solving the other equation, let's subtract 1 from both sides. So the 1's will cancel on the left. The right-hand side becomes negative 5 minus 1, which is negative 6. So we get 4x is equal to negative 6. We wanted to get rid of the 4 in front of x, so let's divide both sides by 4. That will make 4 to cancel on the left, and the right-hand side becomes negative 6 divided by 4. Since both 4 and 6 are divisible by 2, we're going to divide both of them by 2. So negative 6 divided by 2 will give us negative 3, and positive 4 divided by 2 will give us positive 2. So what we ended up getting is x is equal to negative 3 over 2. Okay, so our solution set is 1 and negative 3 over 2. Now please check your solution using original equation. So you're going to substitute both 1 first and then negative 3 over 2 into the original equation to show that both sides of the equation are true. Once you do that, please work on these problems here. And I will move on to problem 1.18. So this is an example with two absolute values. Okay, so we ask to find the solution set of the equation and again check the solution. So given the absolute value of 3x minus 8 is equal to the absolute value of 5x minus 6. So notice that since the absolute values of two expressions are equal, this gives us two possibilities. That either two expressions are equal or one is the negative of the other. So therefore we split our equation into two as follows. 3x minus 8 equals to 5x minus 6, or 3x minus 8 equals to negative, and now watch that we are negating the right hand side, the entire right hand side, minus the quantity 5x minus 6. Okay, now we need to solve each of them separately, both equations. So let me start with the equation on the left hand side. First I'm going to be moving the 5x to the left. So subtract 5x from both sides. The 5x will cancel on the right. The left hand side becomes 3x minus 5x, which is negative 2. X minus 8 equals to negative 6. Now the next step is to move 8 to the right hand side. So let's add 8 to both sides. Adding 8 to both sides cancels the 8's on the left. And the right hand side becomes negative 6 plus 8, which is 2. Then we wanted to get rid of the negative 2 in front of x. So we're dividing both sides by negative 2. So the negative 2 and negative 2 will cancel on the left, giving us x. And the right hand side becomes 2 divided by negative 2, which is negative 1. So the first solution is negative 1. And now let's take a look at the other equation. 3x equals to 8. 3x minus 8 equals to negative times the quantity 5x minus 6. So let's first distribute the minus. When you distribute the minus, you're going to have negative times 5x, which is negative 5x. And then negative times negative 6, that becomes positive 6. Okay, so first I'm going to start by moving the negative 5x to the right hand side. So I'll be adding 5x to both sides, and that makes 5x cancel on the right. And the left hand side becomes 3x plus 5x, which is 8x. So the equation now is 8x minus 8 equals to 6. So the next step will be to move the negative 8. So we're adding 8 to both sides. The 8's will cancel on the left. And the right hand side becomes 6 plus 8, which is 14. Now the next step is to get rid of the 8 in front of x. So let's divide both sides by 8. That makes 8 cancel out on the left, and the right hand side becomes 14 divided by 8. So we can simplify that. 14 divided by 2 will give us 7, and 8 divided by 2 will give us 4. So the other solution is x equals to 7 over 4. Okay, so now to check your solution, again, you will be substituting each of these solutions, first negative 1 and then 7 over 4, turn by turn into the original equation. Okay, so the main idea above is that any equation involving two absolute values will split into two equations, just like we did before. Okay, so if you have the absolute value of ax plus b equals to the absolute value of cx plus d, you're going to split this into ax plus b equals to cx plus d, and ax plus b equals to negative quantity cx plus d. Now let's take a look and solve problems 1.19 and 1.20.